Good morning, everyone. Today we'll start with the question answers of exemplar reflection. Which of the following cases can make a parallel beam of light when light from a point source is incident on it? So there is a point source from which light is incident upon a device. And if it is a concave mirror, in this case, concave mirror, the beam of light is incident upon it and it will be reflected back in such a manner that they become parallel. This one goes from here to here, and this is possible when the light source is placed at focus. On the other case, if the point source light from it is falling on another device and that's a convex lens, okay, so in this case also it will go straight, means after passing through this it will become parallel. So in both the cases, concave mirror and convex lens, the light beam which is after reflection will be formed is parallel. So answer is option A. Question number 2 will be solving after question number 3. Question number 3, under which of the following conditions a concave mirror can form the image larger than the actual object? So if we are taking a concave mirror and if we take, this is pole, focus, and this is center. So when the object is placed here between C and F, light beam parallel to principal axis, rule number 1 will pass through focus, and if it is passing through focus, it will become parallel. So here we can see that the image formed is beyond C and it is enlarged. So the answer will be C. When object is placed between focus and center of curvature, the concave mirror can form images larger than the object. In this numerical, it is given that height, a 10 millimeter long ball pen is placed. So this is the height of the object, and height of the object is 10 millimeter. Now it is placed vertically in front of a mirror. So we have identified that the mirror is concave mirror. 5 millimeter long image. So the height of the image here is 5 millimeter. Ball pen is formed at 30 centimeter. So image is formed at 30 centimeter. It means it is the position of the image, and that is 30 centimeter. But we have just written the data and not consider the sign for it. Here, if we carefully check the signs of height of the image and position, actually this image is formed in front of a mirror. मिरर के सामने अगर ये बन रही है, इसका मतलब ये रियल इन्वर्टेड इमेज है, एंड रियल इन्वर्टेड इमेज इन केस ऑफ concave mirror are always formed on this side, means the third quadrant, and that's why height of the image will be negative because it is inverted image, and V will be negative because it's towards the left hand side of the hole. So be careful while determining these signs. Now the magnification M for the mirror is minus V upon U in case of mirror, and that is also equal to ratio of height of the image to height of the object. Now we put the values minus sign as it is. Value of V. Value of V is minus 30 upon U. U is not given, so let it be just U. H dash is minus 5 and H is 10, which we further can solve, and that will be minus 1 by 2. So this minus minus becomes plus, and that will be 30 upon U equal to minus 1 by 2. We cross multiply and solve the value, then U will be minus 60 and unit will be centimeter. Here the units of height will not affect the result because these two are in millimeter, and here the ratio is also given for the height, and that's why millimeter is cancelled with the millimeter. Now the question is asked that what is the focal length? So for determining focal length, we use the formula 1 upon F is equal to 1 upon U plus 1 upon V, which is the mirror formula. And then we put the values of U, which is minus 60, plus V, that is minus 30. And then we'll take LCM, which will be minus 60. So this will be 1 plus 2, and that will be 3 upon minus 60. Now the value of F will be reciprocal of it, means minus 60 upon 3 minus 20 will be the answer. So focal length will be minus 20 centimeter. Now question number 9. Question number 9, magnification produced by a rear view mirror fitted in vehicles. Now rear view mirror fitted in vehicle is a convex mirror, and convex mirror always forms images which are smaller than the object. So magnification here is less than 1 because height of the image is less than the height of the object. So magnification here will be if this h dash upon h we compare. So if this height of the image is less than this height of the object, okay. So if numerator is less than the denominator, it will be less than 1. Next question, rays from sun. Rays from sun means the object is sun and the sun is placed at infinity. So here the object is at infinity and it is converged at 15 centimeter. So if we are taking a concave mirror and light is coming from infinity and they are focused at point F. So this F, they have given us that F is 15 centimeter. Here it will be minus 15 because it's a concave mirror. Now part 2, where should an object be placed so that size of the image is equal to the size of the object? We can recall that in case of concave mirror, if the object is placed at C, its image is formed at C only and that is of the same size. So which is position of the image should be C and C is double of F, it means it will be 30 centimeters. So answer is option B. Next question, a full length image of a distant tall building can be definitely be seen by using which mirror? Now, if we take convex mirror, okay, that's possible because convex mirror has a wider view. Because if we just check the convex mirror can see the objects placed all over this place, and that's why the image formed here and the behind the mirror is smaller, but it's complete. Okay, plane mirror, you may get confused that the answer can be plane mirror, but in case of plane mirror, if the building is 100-meter tall, at least half of its size means 50 meters should be the size of the mirror to obtain the image. If it is not 50 centimeter, we'll not be able to see the complete image. So answer here is convex mirror, and that's why convex mirror is used in case of shopping malls, at metro stations, parking lots to see the huge view. Okay, and the image formed is virtual and erect. Question number 12. Question number 12 is just we have done in question number 1 also, that in torches, searchlight, headlights of the vehicle, the bulb is placed where? Now, if we just see the torch, in case of torch, if this is the torch portion, here, this place, the bulb is placed and the light goes straight. Okay, so light which is going back should also go in front. So this object, this source of light should be placed near to the focus. Now it cannot be exactly at F because it's extended object. It's not a point size object. So exactly F पे तो रखा हो नहीं सकता, तो F के बहुत पास होना चाहिए, and that's why the answer is very near to the focus of the reflector. Question number 16, which of the following ray diagram is correct? So it's a diagram for concave mirror, and concave mirror there are 4 cases. Incident ray is parallel to principal axis, but here this ray is parallel but passing through near to the F, not exactly at F. So that's the wrong diagram. Here it's passing through to F, so it's again wrong. Here it is bouncing back, so it's also wrong, but this diagram is correct because parallel beam is passing through focus. Now we come to the next question, question number 18. A child is standing in front of a magic mirror. She finds the image of her head bigger. Head is bigger and erect. Bigger, enlarged and erect image is formed in case of concave mirror. Then the middle portion of her body is of same size. It means it should be a plane mirror. And her legs are smaller, means the image is erect. Because all the cases, the image of the child should be erect. And that's smaller. So that's a convex mirror. So answer is C. Next question, question number 19. In which of the following the image of an object placed at infinity will be highly diminished and point size? They are not talking about the nature. They are not talking about that it's real, inverted, virtual, erect, whatever. They're talking about only the size. And all the 4 cases of concave mirror, concave lens, convex lens, the image of an infinite object, which is coming in the form of parallel beam of light, is focused at F. So answer will be D part. Question number 36 of exemplar is a little complicated question and we have to do it very carefully. In this question, when we read the language of the question, we don't get to know that what type of mirror it is. What is the nature of the image form? Like they have just mentioned that size of an image, of an object by a mirror having a focal length 20. So we cannot get to know that this F is plus 20 or minus 20. If it is concave mirror, in that case, this F will be minus 20 centimeter. And if it is convex, in that case, this F will be plus 20 centimeter. Now, M, magnification, it's observed to be reduced to 1/3 of its size. 1/3 of its size means it is reduced. Magnification here. Now, magnification in case of convex mirror. This is for convex mirror, and then magnification will be positive, and that's why it will be plus 1/3. Because in case of convex mirror, the image formed is always diminished. And since it is virtual and erect, the sign is positive. Here, in case of concave mirror, this is about concave mirror. So in case of concave mirror, magnification, when we are taking that object is 1/3, means it is diminished in size. And if it is diminished in size, it is real and inverted. And that's why the magnification is minus 1/3. So these two combinations we have to take care while solving. If we have short of time and then we consider the image to be real. So if we have to choose to do one of the cases in these two, we'll take it as a concave mirror and solve it for the real one. Otherwise, in the complete solution, both the cases should be considered. Now let's take them one by one. Here, if we are taking magnification, M, the formula for magnification is minus V by U for the mirror, and mathematically they are given it as minus 1/3. This minus minus get cancelled, and here it will become 3V is equal to U, equation number 1. Now, from the mirror formula, 1 upon F is equal to 1 upon U plus 1 upon V. 1 upon F, that will be 1 upon minus 20 is equal to 1 upon U. Now, in case of U, we'll put 3V and then plus 1 upon V. Then we take LCM, it will be 3V and 1 plus 3, which will be 4 upon 3V. When we further solve this, this will become minus 1 upon 20 is equal to 4 upon 3V. When we further solve this and cross multiply, V will go to this side here, and that will be minus sign 4 into this 20 will go to this side, and 4 into 20, 3 remains as it is, and that will be minus 80 upon 3. We need to calculate U, where should the object be placed, and U is from this equation is 3V. So that will be 3 into V, and that's why it will be 3 into minus 80 upon 3. So answer will be minus 80 centimeter. So the object should place at minus 80 centimeter. Same thing, by using the same formula and applying the same method, we can solve for this case also.